This lesson shows you how to use exponents to name place value units and explain patterns in the placement of the decimal point. Essentially, we're looking at exponents to do the same thing we've been doing for the past two lessons. First, we need to look at what exactly is an exponent. We can simply define it as how many times a number is to be used in a number sentence. For example, if we have 10 times 10, 10 is being multiplied by itself twice, so we could say 10 to the power of 2, or 10 squared, which is 100. And it's important to note that sometimes you'll see somebody write it as 10 caret 2. That means the same thing as 10 squared. Some computer programs don't allow the exponent. You could look at another example of 10 times 10 times 10, which is 10 cubed, or 10 to the power of 3, which is 1,000. Okay? When you look at this, you can notice that 10 occurs 3 times, so we do 10 to the third. There are also 3 zeros. It's also very important to note that 10 to the third is not the same as 10 times 3. 10 to the second is not the same as 10 times 2. It is that number multiplied by itself. If we were to fill this into the graph, we could have our number along the top, 10, which is the same as 10 times 1. I don't really like that we have the times 1, but it helps you know that you are multiplying it by something. 100, which is 10 times 10, and so on. So if we were to do it with exponents, for 10, we would simply put 10. We could put 10 to the first, but it's not necessary. Okay, so I would not suggest putting that. For 100, it's 10 times 10, which is 10 to the second. Okay, try writing 1,000 and 10,000 in exponential form on your own. You may need to use the caret key, which is about when you hold Shift and hit 6 if you are using a computer program. Okay, when we fill it in, we see that 1,000 is the same as 10 to the third. 10 times 10 times 10, that's 3 times total, 3 times here. 10,000 is 10 times 10 times 10 times 10, so 10 to the fourth. So for this problem here, we have 10 to the fifth power. Now we can write that as a product of tens, and what that's asking for is just for you to write out 10 times 10 however many times. And since it's 10 to the fifth, we're going to do 10 times 10 5 different times. Again, notice that it is 10 times 10 times 10 times 10 times 10, not 10 times 5. Okay? And when we solve this, we see that we have 100,000 as our solution. We can look at this problem of 10 times 100, and we should break it down into the powers of 10, which we would have 10 times, and to get to 100, we have 10 times 10. Okay, so we're breaking down this piece into tens. So then we have 10 times 10 times 10, which is 10 multiplied by itself 3 times. So we have 10 to the power of 3, or 10 cubed. And that is our solution for this. So now what I'd like you to do is to mix today's lesson with what we've been doing in the past few lessons. I'd like you to try solving 3 4/10 times 10 to the third power, or 10 to the factor of 3. So what we're really saying is 3 4/10 times 10 times 10 times 10, which we break down to 3 4/10 times 1,000. If you need to use your place value chart to solve that, you may. If you can do it mentally, you can do it that way. And we see that our solution is 3,400. The way that I would check my work quickly here is to see that I have 3 ones, and I know that 3 times 1,000 is 3,000, so I just did a quick check for that, and then the rest of the numbers followed. Try one more problem. 7 1/10 divided by 10 squared, or 10 to the second power. Okay, what I did here is I did 7 and 1/10 divided by 10 times 10, because 10 squared means 10 times 10. And you notice I put that in parentheses. What that means is I need to make sure that I do this part of the problem first. Okay, think about GEMS or think about PEMDAS. Then I can split it down one more, where I have 7 and 1/10 divided by 100. And I see that my solution is 71 thousandths.